Hello, my name is Mehdi. Today I'm going to present our work with Masashi Sugiyama on generalization guarantees for continual learning with orthogonal gradient descent. This work was accepted at the 4th Lifelong Learning Workshop at ICML 2020. So imagine an agent on the left who wants to learn a sequence of tasks throughout his lifetime. And so he keeps learning, and one issue is that after learning a few tasks, he may start to forget the oldest tasks, and this is called catastrophic forgetting. And so the main challenge in continual learning settings is how to keep learning without forgetting. There are many algorithms that were designed to alleviate this problem. Like there's EWC, HM, OGD, and many other algorithms. So we focus on OGD in our analysis. By the way, it achieves state-of-the-art performance on the continual learning benchmarks. Our motivation is that there is no theoretical analysis that has been derived yet for this algorithm. Either on its convergence, generalization guarantees, its robustness to catastrophic forgetting, and our aim is to fill this gap. And basically we have many contributions to fill this gap. So the first contribution is on convergence. So we find that the model learned by the agent can be written as a recursive linear combination of kernel regressors. So an interesting side result is that the agent learns the residual between the new task and what he learned before. The other result is related to the robustness of OGD. So we find that OGD is only probably robust to catastrophic forgetting with respect to the previous task only. So the result of this result is that we can prove that generalization guarantees or bounds only for the current and previous task only, and not for all tasks. This motivates the OGD plus algorithm, which we propose in this work, which is an extension of OGD. The main difference is that OGD plus also stores the feature maps with respect to samples other than the current task, while OGD only stores samples with respect to the current task. So the result of this very simple change is that OGD plus, we prove that it's robust to catastrophic forgetting across an arbitrary number of tasks. And so the result of this results is that we find tight generalization bounds for all the tasks if we train the agent with OGD+. So there is another result on curriculum learning, which is more a side result. We define the task dissimilarity, and we find that an ordering of tasks that minimizes the dissimilarity leads to tighter generalization bounds. So it means that if the agent learns with a curriculum in which each two neighboring tasks are similar, he learns better. The experiments show that OGD plus outperforms OGD on settings with long-range memory dependencies, even though the models are not overparameterized. We mention that because we make the assumption in the analysis that the model are overparameterized. On the right, you can see the results of a comparison on some baselines. So to conclude, this analysis highlights several theoretical properties of OGD and OGD plus for continual learning. There are still many exciting questions, like how to select samples. Can we extend this theory to when models are not overparameterized? Can we apply this theory to other algorithms, other heuristics? These are all exciting questions, and so if you want to discuss or if you have any feedback, please feel free to reach out to us. Okay, thank you.